Okay, now what we're going to do is start out with an angle that's measured in degrees, and you're going to be asked to do each of these three things. So each example that I'm fixing to work, we're going to do A part, B part, and C part too, okay? Now, A part, draw in standard position. That's something we learned how to do back earlier. We're going to convert to radians. So see, we're like this first example, we're starting out with degrees. We're going to convert it to radians. Now, what I mean by exact, if you remember, what you're going to do to change from degrees to radians is multiply times pi over 180. Well, if you put that in your calculator, because it involves pi, you're just going to have a big long string of decimal places. So exact means that you're going to have to leave pi in your answer, okay? Of course, I'll give you details on how to do that, and you'll see exactly what I mean. C part, now if you remember from the previous section, having the little caret top, house top, however you refer to it, over your theta symbol, that is the symbol for reference angle. So you're going to be asked to name the reference angle for the given angle in degrees and in radians. All right, so the first one here is 225. So we're going to draw this off in standard position first of all, and that's going to terminate in quadrant 3. So I'm just going to give myself a little bit more room over here in quadrant 3. Of course, standard position, you start at the positive end of your x-axis, and you're going to rotate counterclockwise when it's positive. So you'll rotate through your first quadrant and your second quadrant. Of course, that's 180. So the terminal side is actually going to end up being dead center of the third quadrant, okay? Because if you get around here to 180, you got to go 45 more. So like this little portion right here is actually 45 degrees, okay? So that's A part. They just wanted you to draw that in standard position, okay? So like this is A part. Okay, B part, you were asked to convert it to radians. So I'll come back over here. So for B part, we need to take 225 and multiply that times pi over 180. Of course, that's one of the notes that I just gave you just a few minutes ago, okay? Now, the 225 is understood to be over 1. There's some cross-reducing that you can do here with the 225 and the 180, but you also can just use your calculator on this, because you remember I talked about it wanting the answer to be exact, which means we're going to need to leave pi in it. So in your calculator, what you can do is just do 225 divided by 180, and then just go to math and choose fraction. You know, just like just have the calculator reduce it for you. That's perfectly okay. So the 225 and the 180 will reduce down to be 5 over 4. But then you need to remember to put the pi back in your answer. Of course, that means it's just going to end up staying in the numerator. So this would be 5 pi over 4 would be the radian measurement for the 225 that's in degrees, okay? Now, C part, you're asked to do reference angle. Like I said, reference angle is something that you learned in the previous section. So back over here where we drew this in standard position, remember your reference angle is the angle that's between the x-axis and the terminal side. Well, the line that I drew here is the terminal side, and then of course here is your x-axis. So this area from here to here is the part that is your reference angle, okay? So reference angle would be 45 degrees. Okay, now you're also asked to name reference angle in degrees and in radians. Now, two different things. You could take the 45 and do exactly what I just did right here. You know, that's what we learned, to multiply by pi over 180. But 45 degrees, if you look back at that list of angles that I had you to write down a while ago, 45 degrees is one of those that I said is one that you'll end up using a lot, and just basically you just need to commit it to memory. So straight off of that, I know that 45 degrees is pi over 4, okay? If you multiply it times pi over 180 and reduce, then you're still going to end up getting the same thing, okay? Now, here's something I want to point out to you that's going to help us a little bit later, kind of save us some time. If you notice, of course, right here we ended up with pi over 4 as being our reference angle. Back up here when we converted our angle over to radians, if you notice it's got pi over 4 in it, okay? You're going to see that with those familiar angles, okay? That's not going to happen with just any angle, but it will happen with the list of familiar angles, like if you're dealing with the 30, the 45, and the 60, okay? Okay, let's look at another one. All right, so this time I have negative 160, okay? Not a big difference here other than just the fact that it is a negative angle. Okay, so let's draw this off. This is actually going to end up terminating also in the third quadrant. Now this time, again, I'm going to start over here at the positive end of my x-axis, but I have to rotate clockwise because of it being negative. So when I rotate down through the fourth quadrant, of course, that's 90 degrees. So to get from 90 to 160, I need to go 70 more, which is going to put my terminal side up here towards the top part of that quadrant, okay? Which means this portion right here is 70 because I had to go through the fourth quadrant, which was 90, and then I had to go 70 more, okay? Now, that's A part, because remember, A part was just draw it in standard position. Okay, B part is to change it to radians. So we're going to multiply this times pi over 180. Now, anytime that your angle is negative in degrees, it will still be negative when you convert it to radians, okay? Now, just like I did a while ago, in your calculator, you can just do 160 divided by 180, and then just let your calculator reduce it for you. So I get 8 over 9. Again, that would be negative 8 pi over 9. Okay? Now, C part was asking for reference angle. Okay, so go back to where you had your drawing. And again, remember, reference angle is the part that's between the x-axis and the terminal side. That's this portion, not this 70 degrees, because the 70 degrees doesn't touch the x-axis. Reference angle has to be the part that touches the x-axis. So, if this is 70, though, we know that this part then would have to be 30. No, I'm sorry, 20. Let me draw it right here. Sorry, 20 degrees. So my reference angle is 20 degrees. Now, a while ago, on that first example, I had 45 degrees, and I was just able to get that straight off that list. 20 degrees is not one of those that we work with a lot, so you're going to have to go ahead and, just like I did on B part, and multiply by pi over 180. So if you do your 20 divided by your 180, you're going to get 1/9. Again, you've got to remember to put the pi on the top. Of course, the 1 is understood to be in front of the pi. You know, if you want to put that there, you can. You still are seeing the pi over 9 here and here, but of course, where we're going to end up using that most of the time is going to apply to the 30, 45, and the 60, okay? All right, I'm going to take you through one more, and that's only because this one is actually more than one rotation, okay? Because if you remember, 360 is one rotation, so this, of course, goes even beyond that. Okay, so we need to start off by drawing it in standard position. let's see. I think this is going to end up in the third quadrant as well. Okay. Well, I've picked all of them that have ended up in third quadrant. Okay, so you start at the positive end of the x-axis. Of course, you're going to rotate all the way around, which is 360. So if you do 495 minus 360, you get 135. Okay, so when I start back around, I'm going to go 135 degrees, which is actually going to stop me in the middle of the third quadrant again. Okay, so there's my standard position. So there's A part. Okay, B part. So I've got negative 495, and I've got to multiply that times pi over 180. So you can use your calculator. 495 divided by 180. And change that to a fraction, so you get 11 over 4. So that would be 11 pi over 4. Okay. And last, C part is reference angle. And again, that's always the part that touches the x-axis. This is the part that's the reference angle. But if this part's 45, then that means this part also has to be 45. And of course 45 again is one of those that's on the list. So just learning that as we go, 45 degrees is pi over 4.